dears, this is Raji. In this video, we are going to learn about the difference between molarity and molality. We have already discussed this concept and we have done a lot of problems also related to that. If you haven't watched those videos, you can click this link and go through that. Okay. So let's start with what's the difference between molality and molarity. To understand the concept better, we are going to prepare 2 molar solution of glucose. At the same time, we will be preparing 2 molar solution of glucose also. Okay. Yeah. What will be the molecular mass of glucose? That is C6H12O6. 1 mole of glucose will be weighing 180 gram. If so, what will be the mass of 2 moles of glucose? That will be equal to 360 gram. So, to prepare 2 molar solution of glucose, we will have to weigh 360 gram of glucose. Okay, we are weighing 360 gram of glucose and transferred it into this round bottom flask. Now, we are adding little bit of water into that, dissolving glucose and then making the volume up to 1 liter. Now, this will be a 2 molar solution. Got it? So, here solute as well as a solvent together will be 1 liter. Okay? Yeah. Now, how to prepare 2 molar glucose solution? For that, we are again weighing 360 gram of glucose. We are transferring that into this round bottom flask carefully. And after that, we will be weighing 1 kg of water. Then, we will be transferring this water completely into this round bottom flask. Correct? See, the resulting solution will be 2 molar solution of glucose. Okay. Now, one question comes to mind. In 2 molar glucose solution also and in 2 molar glucose solution also, the same amount of the solute, that is 360 gram of glucose is present. Agreed? Also, 1 kg of water will be equal to 1 liter of water also. Correct? Yeah, because density of water is 1 kilogram per liter, right? Then what is the difference between these two solutions? To understand the difference between these two solutions, we will be considering the volume of the solution in both the cases. See this one. When we prepare 2 molar glucose solution, the volume of the solution is 1 liter only, right now? Yeah. Whereas, when we prepare 2 molar glucose solution, the volume of the solution is not 1 liter. Can you see this one? It will be slightly greater than 1 liter. Why? Because we have completely transferred 1 kg of water into that. Then, in addition to that, some amount of the solute is also present in this, right? So, together, if we consider the volume of the solution, it will be slightly greater than 1 liter. Here, 2 moles of the solute will be present in exactly 1 liter of the solution. But here, 2 moles are present not in 1 liter. It will be slightly greater than that. Say 1.025 liter we will write. So, if you are considering 2 molar solution and 2 molar solution, the concentration of the solution in terms of volume will be slightly less in the case of molality compared to molarity. Remember, the change in volume will be clearly seen if you are taking greater amount of the solute. If you are taking lesser amount of the solute, the effect won't be clearly seen. Okay, you can remember that also. Now, see this one. We are going to see what will be the effect of temperature on molarity and molality. For that, again, we are preparing 2 molar solution of glucose. For that, we have taken 360 gram of glucose. We have weighed it, transferred into the flask, and now we are adding sufficient amount of water so that we are making the volume up to 1 liter. See, now this is a 2 molar glucose solution. When I was doing this experiment, the temperature outside was 30 degrees Celsius. I have kept the solution as such. Okay. Now imagine that all on a sudden the temperature outside is changing to 60 degrees Celsius. then what will happen? See, the volume of the solution has now become slightly greater than 1 liter. What's the reason for that? Because if we increase the temperature, water expands. Correct? Yeah. Now, what will happen to the molarity of the solution? Yeah, number of moles are same only. That will be equal to 2 moles of glucose. But it is present not in 1 liter. The volume of the solution has changed. Okay. Suppose it has increased to 1.015 liter. So what will be the new molarity? That will be equal to 1.970 molar, we will say. Correct? Yeah, the molarity is changing. Now, the same solution I am keeping as such. Imagine the temperature of the surrounding is changing all on a sudden. It is reducing to 10 degrees Celsius now. Then what will happen to the volume of the solution? See, it is slightly less than 1 liter because when the temperature decreases, water contracts slightly, right? Now, 2 moles are present in 0.987 liter. It is slightly less than 1 liter. Agreed? Now, what will be the molarity of the solution? It has become slightly greater than 2. That is 2.026 molar. So, remember, molarity of the solution, it changes depending upon the external temperature. Is it clear? Now, we will see what will happen to the molality of the solution if the temperature changes. See, we are adding 360 gram of glucose into 1 kg of water, right? As we are not considering the volume in case of molality, molality is not affected by the temperature, right? Because the mass of water is not affected by the temperature. At higher temperature also, lower temperature also, 1 kg of water will be exactly weighing the same only. So we can say that molality is independent of temperature, whereas molarity changes with temperature. Got it? Now let's see the effect of pressure on molarity as well as molality. To understand the concept better, we are going to study this graph. Here we have the density of water and here we have the temperature in degrees Celsius. Suppose when we were carrying out the experiment, the temperature outside was 20 degrees Celsius and 1 bar pressure. Okay, so that time what will be the density of water? It will be almost equal to 1000 kilogram per meter cube. Okay. Now, at the same temperature, we are applying a very high pressure outside, say 50 bar. So, that time, what will happen to the density of water? See, can you see this one? The density of water is increasing. So, density will be equal to mass by volume. Mass of the solution will not be changing, right? Yeah. So, what will be changing? Volume of the solution slightly decreases. Okay. So what will happen to molarity? Molarity is equal to number of moles divided by volume of the solution in liter. When the volume of the solution is less than 1 liter, what will happen to molarity? Of course, it will be changing, right? So we are telling that if we are changing the external pressure, okay, definitely molarity also changes, correct? Now at the same time, what will happen to molality? It is the number of moles present in 1 kg of the solvent, right now. So mass is not affected by the change in pressure, correct? So molality won't be affected by pressure. But you will have to remember one more point. When we are carrying out a chemical reaction, it will be mostly at atmospheric pressure only, right? Yeah. So this changes will happen only at a very high pressure. Under normal atmospheric conditions, you can't make out any changes in volume. So we are just concluding that at high pressure, molarity will be affected. But molality will not be affected. Understood? Okay. So after learning this much, definitely you will be able to answer this question. Read and find out which of the following is dependent on temperature. Molality, molarity, mole fraction and weight percentage. Which is answer? Yeah. Molarity is temperature dependent, right? Yeah. Yes, so that is the answer. Now, see one more question. Differentiate between molarity and molality in a solution. What is the effect of temperature change on molarity and molality in a solution? In the same way, read another question. Define the term molarity of a solution. State one disadvantage in using the molarity as a unit of concentration. Right? See, these questions were asked in previous year's board papers. Okay. To answer this kind of descriptive question, we have a table. So, if you are getting differentiate between molality and molarity, how to solve that question? Had better you make a table like this. Okay. Yeah. First, define what is molality and molarity. Then, unit of molarity will be moles per liter, whereas unit of molality will be moles per kg. And molarity will be affected by temperature and pressure, whereas molality will not be affected by temperature and pressure. Usually, molarity will be denoted by the symbol capital M, whereas molality will be denoted by small m. As molarity is affected by temperature, sometimes you may get some wrong measurements also. So, it might not be precise and accurate sometimes, whereas molality will be more precise and accurate as it is not affected by temperature and pressure. So, what's the answer to this question? What's the disadvantage in using molarity as a unit of concentration? What's the answer? It will be affected by temperature. Okay. Depending upon the temperature, molarity changes. Got it? Hope you might have understood the difference between molality and molarity. See you in the next video. Till then.